All right, let's begin. Today we're talking about simplifying radicals. So you need to know that the principal root is the positive root. So for most everything we're going to be doing this unit, I only want the positive answer, not the positive and negative answer, just the positive. So with the principal root. You do need to know that the number here inside the check mark is called the index number. That is the index. This is important to remember because I will be referring to these by their actual names, not by their locations. So we have an index number here, up here in this area. We have the radicand, which is right here, and that's what's underneath the radical sign. And the sign itself is called the radical sign. It is not a square root symbol. It is a radical sign. And over here on the right-hand side was just an example I found on the internet, a picture of it when I was posting it, and we're going to go into detail as to what that means in just a second. So, on the worksheet that we had for homework tonight, I did a lot of the problems on the right-hand side of the page. So you will take these into your notes, and then you can put them and transfer that over to your homework paper when you get back to school to get it. So the first thing we're going to do is we're going to make a factor tree of 98, meaning I need to, what goes into 98? Well, because it's an even number, I know a 2 goes in for sure. So if I divide 98 by 2, I get 49. And then 49 is not prime, it's still factors, and that is 7 times 7. So now at the bottom of each one of these branches or roots, whichever one you want to call it, I have prime numbers. To simplify, you need to recognize the fact that within the radical symbol, right here where the check mark piece is, there's a number, except for square roots. For square roots, which is what this is, the number that's there is a 2, we just never write it down. So you need to remember with square roots, I'm looking at a 2. And what you're going to do is for these problems is I'm going to tell you a little story to help you remember what's going on. And the story goes as such. The radical symbol is a prison. And within that prison, I have, in this case, a 2, a 7, and a 7. Now, if you can find yourself, if you and however many other people you need to find can make up this number, their index number, you are allowed to break out of prison. So in the case of this problem, I have a 7 and a 7. I have 2 7s, which matches the number in the index. So they get to break out of prison. The sad part is that anyone who breaks out of prison, only one of you will survive. The other will perish. And then who's left in prison is whatever numbers aren't matched up with someone. So in the case, once again, this is a square root, so we're matching them in pairs. That 2 did not have a partner, so that 2 remains in prison. So the simplified form of the square root of 98 is 7 square roots of 2. And that's it. So we're now going to go to the second one, 343. Well, when I did this problem, I knew it wasn't divisible by 2, or any even number for that matter, because that's not an even number. I tried 3 didn't work. 5 we know is not going to work because it does not end in 0 or 5. So the next logical number to try is 7, and 7 divides evenly. So it's 7 times 49, and 49 is actually 7 times 7. So there are my 3 prime numbers, but I'm looking at a square root. So once again, that index number we just talked about is a 2. So I can match them up. I can pair numbers up. So I'm going to put these 2 guys together. They're going to break out of prison. One of them will survive. The other will die. I make my radical symbol, and whoever was not paired up with someone remains in prison. So that's a 7. So the simplified version of 343, the square root of that is 7 square roots of 7. In other words, we're learning to simplify because you are no longer allowed to give me answers in decimal form for radicals. Let's do one more square root problem. It's 245. I look at 245 and I see a 5 on the end, so I know it's at least divisible by 5. So let's go 5, and that goes 4. 49. 49 is a popular number today. So that's 7 and 7. Once again, my index number is a 2, so we are matching up in groups of 2. 1 7 survives escaping, 1 does not, and the 5 had no partner, so he must remain in prison. 256, let's go ahead and factor tree. I know it's even, so at least I know I can divide by 2. 128 is still, I see that because I have a 12 and an 8, that's going to be a 4, at least it's divisible by, and sure enough, that's 32. 4's factors are 2 and 2. 32's factors are 4 and 8. 4 is not prime, that's 2 and 2. 8 is not prime, that's 2 and 4. But a 4 is still not prime. All right, so now every number at the bottom of a branch is prime. Now, my index number is a 3 this time. That means I have to group in 3s. It takes 3 numbers to break out of prison now. So I'm going to put these 3 together. And look, I can make another 3. Oh, but I can't. These 2 right here, there's no one to match up with them. So, what happens? Well, this group here, I get to take 1, 2, is going to manage to escape. Out of this group, a 2 escapes. The others all die. What's left in my radical? Well, I have the 2 right here, and I have a 2 right here. So when I work this out, I get 4. Cube root of 4 is the simplified answer for the cube root of 256. Negative numbers. I can take the roots, if it's an odd root, I can take a cube root or a 5th root or a 7th root of a negative number. I cannot take even roots. I can't do square roots or fourths or sixths or so on and so forth. So in the case of this problem, the first thing I do is I do 189, which I can see is going to be a 9, which leaves me 21. That's 2 and 7. That's not 2 and 7, Mrs. Miller. That's 3 and 7. And 9 is 3 and 3. I am looking at a cube root. My index number up here is a 3. So I'm going to take these 3 3s. They're going to become a group. They're going to break out of prison. 1 will survive. 2 will be left in the tunnel. Now, let's talk about the negative piece. You could leave the negative on the inside, but since we have a positive prison here, we must take the negative out with us. So everything stays positive in the radical. I'm pretty much not going to talk any longer. I'm just going to work out the last group of problems for you. This time we're grouping in groups of 4s, so there are 4 3s right there. 1 comes out. The others get left behind in the tunnel system, and we only have the number 5 alive and well in our happy little prison. Now, as you do these problems, many of you will get very quick to recognize who are perfect cubes or perfect fourths or perfect squares, because you're going to do them enough times that life becomes a little faster and a little easier. And to our last slide now. You'll also get very fast at making these factor trees the more you do them. All right, and here's a biggie. We are going to be doing by 6s this time. All right. So once again, the index number tells you how many you are putting together in a group in order to break them out of radical prison. Remember, one will only survive the breakout, and then anything else that did not have a mate or was not able to escape with has to stay in our little prison. And remember, it's a happy prison, so if we're talking about negative numbers, they need to come to the outside. All right, tomorrow we will add variables to all of this.